Welcome to The Explainer. Have you ever really stopped to think about what makes your phone, your laptop, or your gaming console actually tick? Well, today we're going to pull back the curtain and take a look at the secret blueprints that bring order to all the chaos inside your favorite gadgets.
All right, let's just jump right in with the big one. What is this secret blueprint? You know, the master plan that turns a whole bunch of chips and wires into the powerful machine you're probably watching this on right now?
The core idea is actually pretty simple. Think about it. If you were going to build an amazing treehouse, you wouldn't just start nailing random boards to a tree, right? Of course not. You'd need a plan, a blueprint, so you know where the walls go, where the ladder goes, where the secret slide fits in. Well, it's the exact same thing with a computer.
Okay, so what do we call this secret blueprint in the tech world? Let's get into it.
And here it is. The fancy term is hardware architecture. This is the master plan. It's what decides how every single part, from the brain of the computer to its memory, all talk to each other and work together. I mean, without a good architecture, you just have a box of really expensive, useless parts.
And what's really wild is that one particular design, one that was dreamed up way back by a genius named John von Neumann, basically became the standard. It's called the von Neumann architecture, and it's like a universal recipe book that pretty much every gadget you own has been following for decades. It's really the DNA of modern computing.
And that right there gets to the heart of why this is so cool. If you can redesign the blueprint, you can totally change what a machine can do. Rethinking the whole plan opens the door to all sorts of new possibilities. We're talking smarter AI, computers that are just unbelievably fast.
Okay, so if the architecture is the plan for a whole city, who actually lives there? Let's go meet the main players that make up this little high-tech city inside your computer.
First up, you gotta meet the most important resident of our digital city, the CPU. This is the boss, the mayor. It's the brain of the whole operation, in charge of carrying out commands and crunching billions of numbers every single second.
And I love this analogy because it just makes everything click, right? The CPU is the mayor, making all the big decisions. The RAM is like the town square, where info hangs out for quick meetings. And the bus? Well, that's the super fast subway connecting everything together.
But, of course, the mayor can't run the city all by themselves. The CPU has a whole crew. You've got memory, which is kind of like its short-term notepad and its permanent rulebook. Storage is the giant city library. The bus is the whole highway system. And then you have the I/O devices. That's your keyboard, your mouse, your screen, the gateways to the outside world.
So this brings up a pretty important question. We've got all these parts, we've got this whole city, but how does it all actually do anything? Moment by moment, what happens when you click to open a file or play a video?
Well, the answer is this simple but relentless four-step loop. This is literally the heartbeat of your computer. The CPU fetches an instruction from memory, it decodes it to figure out what it's supposed to do, it executes the action, and then it stores the result, and then it does it all over again.
And here's the part that just blows my mind. That little four-step dance, it doesn't happen, once or twice. In the computer you're using right now, it's happening over 3 billion times every single second. That incredible speed is why everything feels like it happens instantly. Okay, so we've got the basic beat, the basic rhythm of the computer, but how do we make it go even faster? Let's check out some of the clever tricks that computer architects use to really crank up the speed. See, not all blueprints are created equal. That classic von Neumann architecture we talked about, it uses one shared highway for everything, both instructions and data. It's kind of like a kitchen where you do your prep and store your food all in the same tiny space. It works, but it can get crowded. Then there's the Harvard architecture. This one builds two separate highways, which can be way faster. It's like having two kitchens, one for prepping and one for cooking. That's why the simpler von Neumann style is perfect for general stuff, like your laptop. But that faster Harvard design gets used in specialized gear, like things that have to process a ton of data really, really fast. And on top of that, modern CPUs have some amazing tricks up their sleeve. There's something called pipelining. Think of it like a factory assembly line, where the CPU is already starting the next task before it's even finished with the first one. Then there's parallelism. That just means using multiple workers, or what we call cores, to handle a bunch of different tasks all at the same time. And to keep all this data straight, computers use what's called a memory hierarchy. The analogy is perfect. The absolute fastest memory is called cache. Think of it like your pocket. It's small, but you can grab what's in there instantly. Then you have RAM, which is like your backpack. It holds more, but it's a little slower to get things out.
And finally, you have your main storage. That's like a giant warehouse. It can hold a ton of stuff, but it takes the longest to go find anything.
All right, so we've seen the blueprint, we've met all the players. For this last part, let's look at where this is all going, and maybe how you could be the one designing the next big thing.
I mean, it's just incredible how far computer architecture has come. We went from computers in the 1940s that literally took up an entire room to having something way more powerful that fits in your pocket. And it's not stopping. Right now, people are working on totally mind-bending stuff like quantum architectures for the future.
And look, this isn't just some history lesson. Think about all the big challenges we're facing. Smarter AI, creating greener, more sustainable tech. All of that depends on new ideas in computer architecture. The folks who really get these blueprints, they're the ones who are literally going to build our future.
And at the end of the day, that's what this is all about, making a real impact. Whether you're talking about building robots that help people, designing medical devices that save lives, or just creating the next big thing in entertainment, it all comes back to having a really smart blueprint to start with.
So I want to leave you with this one last thought. You now know the basic rules of the game. You understand the fundamental blueprints of how computers work. So what's next? What amazing new blueprint will you design? The next giant leap forward in tech? It could totally start with an idea you have right now.